Well. Hello. So I think we are live now, which is good. Um, I haven't been able to live stream for like 3 weeks now, so I've been a little bit busy. But I went ahead and figured out today's objective before I went live, and so for today we are still refactoring the code. And for today, we are just going to do the baseline model for the insurance premium and do the random forest regressor model for insurance premium, because for this project, we are using the same variables to predict insurance premium and also customer lifetime value. So today, we are just going to get the baseline for insurance premium. We'll get a random forest model for it, look at the metrics for random forest model, and then do visualizations for the random forest regressor model, and then we'll do the same thing for the customer lifetime value. So basically we have two y variables that we are going to be looking at, right? Customer lifetime value and insurance premium. And then after that, we'll switch to Jupyter Notebook, because Jupyter Lab is not very good at showing plotly visualization. So we'll switch to Jupyter Notebook, and then we'll look at different visualizations. And eventually we'll export our model, and then next week we'll start building our data science app using Plotly Dash. So that'll be fun. So with that being said, let's go ahead and begin. Actually, I need to run everything. Uh, yeah, I need to run everything prior to this. So go ahead and run our notebook. And let's get over here real quick. So this is the notebook I'm using to do the refactoring. And this is the original notebook. Alright, so first we'll start by doing the baseline model for the insurance premium. And we are going to be using the mean for the baseline. All right, so everything um, up until here has been run, which is good. Let me say extract is not defined. All right, so let's go and run this, and then So this is our x values. Originally we had like 26 columns, but we ended up choosing only 12 columns for the data. And this is our test values and our validation data. So we have our training data. Y train is insurance premium. Y2 train is customer lifetime value. And then this, I should probably maybe rename it. So let's call it premium. And then train, and then let's call this customer lifetime value. Customer lifetime value, CLV train. So this way we will know that, hey, this let's say premium train is equal to training data for insurance premium prediction, and then CLV train is equal to training data for customer lifetime value, and then X train is equal to X data for customer lifetime value and insurance premium R. So this way I won't get confused as like what does these things mean. So that's our X train, and then our testing data. So with that being said, let's go ahead and continue getting the main baseline for insurance premium auto. No, that's the first Y value that we are trying to predict. Main baseline for insurance premium value. Let's call it prediction. Okay, so basically we are using the mean for the baseline, and we are doing Y train dot mean. In this case, we are doing premium. Right, is that what I called it? I called it premium, yeah. So premium train dot mean, and then the error, let's call it and then we get our mean absolute error for our mean baseline. So we can use scikit to learn mean absolute error. So we can do error here. Looks like I need to run this again and change the name here also. Same thing. All right, so this is the main baseline, and let's run this again now. So this is our error values. So these are our errors for each column. And then let's go ahead and import scikit-learn from sklearn.metrics. Import mean absolute error. Is that what it's called? I think it's called mean absolute error. So Classification, we are looking for regression. So for regression, we are looking at mean absolute error, and we are looking for mean squared error. Those are the two metrics I'm gonna use. So mean absolute error, so just mean absolute error, that's what it's called. Mean squared error. Alright, so mean squared error. So now that we have it, we are going to be using this. So let me see. How do I want to do this? Alright, so how you calculate mean absolute error and mean squared error is that you provide a true value and the predicted value. So in this situation, our true value is it going to be equal to our premium train. Alright, that's our true value. And then so this is mean absolute error for training data. And then we are going to get our predicted value is equal to what we calculated here, which is the mean, which is mean times the length of our true value. You know, and the reason why we do this is because when we do mean absolute error or mean squared error, the scikit-learn library is expecting us to have it's expecting us to have the, what am I saying? It's expecting it to have the same length. So we have to do what we calculated to be our mean, and then it is going to take it and put it the same length as this. And I can go ahead and create a new thing here. And basically this means absolute error is basically going to do the same thing that we did. It is going to calculate the difference between the mean, right, and the premium and what we calculated here, and then it's going to take the absolute value. So this is how you do it manually, but what I'm about to show you is how you do it using scikit-learn. It should give us the same result. So it's gonna be mean absolute error and then we put in our true value and then our predicted value. Alright, and let's go ahead and copy this, put it here. Alright, it's throwing an error. Let's see what the problem is. Let me see. Oh, we need to put this in a list format. So let me show you why this was throwing an error, just in case we are wondering. If I go ahead and copy this and put it here for 1 second, and here if we do mean, you see, no, if I do, my bad, predicted value is gonna give me a single value. See, it gives me a single value because I'm just doing mean times this, but what I needed to do is put this in a list. Put this in a list. Now if I do this, it's gonna basically take the value that we calculated here for the mean, and then it's gonna multiply it times the length of this, which is what I wanted. So if you're wondering why it was throwing an error, that was why. So let me go ahead and X this out. I don't need it. This is what we need here. Alright, so basically saying that the mean absolute error for the training data is $25 in this case. Let's go ahead and round it out to 2. And then so if we do it manually like I was doing earlier, we'll still get the same value of $25.39. So you could do it using scikit-learn like I did here, or you could do it manually. In the original notebook I did it manually here, but for this final notebook I'm gonna do it using scikit-learn. So with that being said, let's go ahead and copy this and put it here. Okay, so let me see. We don't need this. Alright, so by guess assurance premium would be this, and we will be off by that's strange. This just worked a second ago. For some reason it's not working anymore. Numpy that floats if the object is not callable. Oh. That's because here see this, so the reason why it's giving me this error right here is because down here I ran this code cell, and by running this code cell I replace the variable mean absolute error from scikit-learn with mean absolute error equal to this. So now my code is no longer recognizing mean absolute error as a scikit-learn library. It is now recognizing it as an individual value. So I need to run this again. By running this again, I will reassign mean absolute error from this value right here to this value. So let's go ahead and do that, and then this will disappear. Yeah, that disappears. So all right, so we got that. So we got that, and let's go ahead and repeat this process, but we'll do it for the mean squared error. So now instead of doing mean absolute error here, we'll do mean squared error. And let's rename this to mean MSE. So the mean squared error for the baseline is $1,192.20. And we could repeat this process for the testing data, but I just kind of wanted to kind of have some kind of baseline for the values of how off we are in the error. And we could also do this, like I said, let's see. So I did this for the testing data. Let's do it for the training. I did this for the training data. Let's do it for the testing data also. I'm trying to think here for a second. I could have done this. I'm thinking, so I could have done this for the entire data set instead of just the training data. I wonder if the testing data will give us the same results. So So basically, we repeat the process that we have above here. And then all right. So let's call it min test is equal to premium test, and let's call this min test. And then I don't need this value right here. And then our true value is gonna be our premium test, our predictive value in this situation. Let's give it different variable names so that we could easily pull this up later. I don't like to override my variables. True test. Alright, so we got this test, true value, and let's repeat the same process here. Well, we don't need this again because we already have this information above. Hold on, I want to check something. Python print statement multiple lines. Yeah, this is what I'm looking for here. Hmm. Okay, I think okay. If I just add comma right here, would it work? No, not really. So let me see. Cause I'm trying. I don't want this to be so long here. Mm, but the problem is that if I add this, oh, that might work. Hold up. Hmm, that might actually work by just by adding this. So okay, think I figured it out. Maybe we'll find out. All right, because I don't like how long this thing is. All right, so I think I've made all necessary changes. So we've got main test and then premium test. All right, test. Okay, and then all right, let's go ahead and run this. That didn't work. All right, trying to figure out how to make this go onto multiple lines. Yeah, that's not working. Let me see if I can find something real quick. Oh, I think I might need a plus in front of it. Maybe. Let me see. Do I need to add a plus here? And maybe a plus here? That doesn't make sense. Mm. Trying to see how to add line breaks to it. I mean, um, with slash n, this will go into a new line, but I don't want this f string later to be too long. So Python f string. I didn't know I could use triple quotations inside this. So hold on, I think I might have figured out something. So could I do this? And then does that work? Oops. This might work. That might work. So let me try this out real quick and see. If it doesn't work, then I'll just move on. I'll figure it out later. I'll figure it out eventually. And I need this to cancel. Mm-mm. It works. Oh, but then now the problem is that everything is broken up here. So I want to add a new line here, and let's call this well, I was trying to do HTML here, but that doesn't work in Python, but that's okay. All right, I'm done with this. Let's go ahead and move on. Mean squared error. All right, that looks good enough. So basically, it doesn't matter if you're doing the test, if you're using the test data to establish the baseline, or if you're using the training data to establish the baseline. The values are very close. You could have also established the baseline using the entire data set, but using the test data, the predictive value is $92. Using the training data, the predictive value is $93, and we'll be off by this for the mean squared error, and this for the mean absolute error, and then this is the values for the test data. So basically, in this situation, it doesn't matter if you're using the test or the training data, because the values are very close by. So now that we've done the mean baseline, let's go ahead and work on the random forest model. So let's see here. And of course, in this situation, I've already written all this code, so I won't be writing these codes again. All right, and then of course, most of this code is just refactoring what I've already done. So now we are getting the mean squared errors. And then we can look at the coefficient if you like. Oh, actually, no, this is linear regression. What am I doing? Oh my gosh. No, the random forest model. Sorry. No, the random forest model turned out to be the best model in this situation, so I decided to go with the random forest model. Yeah. So this is the future importances from this, and then I'll go back and run all this code here just to make sure it works. But in the meantime, I'm just gonna copy what I have. Okay. So we are basically gonna run this code just to make sure it works, and then we're gonna do the exact same thing for customer lifetime value. Get the baseline for customer lifetime value. Get the random forest model, the metrics, and the visualization, and then we'll do sharply plot. And after that, we'll move on to Jupyter. We'll switch to Jupyter Notebook to do the visualizations, because Plotly Express or Plotly and visualizations doesn't work in what am I thinking, in Jupyter Lab. All right, so random forest regressor instantiating this. Let me go ahead and do this just to make my life a little bit easier. So I'm just gonna call it, I'm gonna say well, x is already established. I'm gonna say y train in this situation is equal to, what's it called, it's equal to premium train. All right, let's go and run that. um I want this to be rounded. All right, and let's make this bold. All right, so we have our run regression models. Mm-mm-mm-mm. Now let's go ahead and get the importances. So let's get and run. Oh, I need to import matplotlib first. So let's go back up here. See that. All right, let's go and run this. Um, okay. All right, so that looks actually good. I like it. So this is hmm. So this is a visualization for the random forest model. Feature importances. So basically, a random forest model is saying that these are the features that are most important in determining the insurance premium. Maybe I'll just limit it to the top 5. Um, I think I might do that. Let me go ahead and do the same for the customer lifetime value, and then I'll decide if I want to just limit the top 5. If I just want to limit it to the top 5, we'll see. Just give me a second. So let's do the same thing we did above, but now let's do it for the customer lifetime value. I feel like I need to emphasize this. All right, so let's begin with the baseline, and this time we are just gonna do it for the training data, since both the training data and the test data give us about the same result. So in this situation, we call it CLV. CLV is customer lifetime value, and let's call this train. You can just delete all of this. Actually, I think I might just call it CLV. I don't like to override my existing variables. So and then our predictive value is gonna be okay. So the mean absolute error all right, and hold on. I'm gonna change this. I just got this. Actually, this is right. Mean squared error. Alright, so I'm just gonna do a double check real quick. Alright, so I'll see average training data, which is customer lifetime value training data, the true value, the predictive value, the mean absolute error for customer lifetime value, mean baseline, the mean squared error, and also okay, so that looks good to me. All right, so basically the customer lifetime value is $7,954 and will be off by 4,000. That's for the mean absolute error, and for the mean squared error will be off by this much. All right, so that's a huge number. Real quick before I move on, okay. And so basically our model's prediction is the mean from our model's prediction is $92. And this is kind of like, but then the mean absolute error is 4.31, while our mean absolute error for our baseline is $25. And the goal with this error is that you want to reduce your error metric, okay? And then for this one, the mean for the baseline, the mean squared error was 1,192, and then the mean squared error for our random forest regression model is $35. So the goal with regression is to reduce the error score. Well, the goal, not necessarily the goal for regression, but the goal with the model, right? So the goal with performing using a model is to reduce the error score. And yeah, so the error score that we got from the random forest model is way lower than what we got from the baseline. I just wanted to show you that. So now that we have these values, let's go ahead and do the same thing we did above. So basically we are gonna do this, but now we are gonna do it for our customer lifetime value. So my Y train in this situation is CLV. Oh, yeah, that's wrong. Hold up. um, yeah, that's not right. So no, that's right. I'm trying to make sure I'm not like mixing up my data. Let me scroll up here a little bit. So here, my train, and then test. Okay, that makes a lot of sense because I was like, I just wanted to make sure I'm not messing things up. So yeah, so this is what I was saying that might be wrong. So I was like, wait, this doesn't add up. Okay, that makes a whole lot of sense because I was like, I wanted to make sure I defined what my white test was. I'm guessing I still had white test in memory. That's why the answer was right, but I forgot this step before. All right, so let's go ahead and also add it here. All right, so random forest again. Let's call it CLV. Again, I don't like to override my existing variables. If I wanted to do something with the insurance premium model, I want to be able to do something with the insurance premium model without having to run these code cells again. That is why I don't want to like override it, and I don't want to override my existing variables. All right. So basically, our model predicts that the insurance premium, or yeah, the customer lifetime value is about 7,900 and this, and the mean absolute error is this, and the mean squared error is kind of high. So let's compare. Let's see this versus our baseline. All right. So our baseline mean squared error was $4,345. But our random forest model is way lower than that, and then the mean squared error is about 17 million. That's kind of high. And mean squared error may not be a good metric for measuring this, for measuring the model's performance, um, but it is still better than what we have from the baseline. So that's the whole point, right? The reason why we establish a baseline in the first place is to, well, check and make sure that the models we are building is actually improving upon the baseline. Because what's the point of building a model that is not better than just making a random guess? All right. We are trying to build models that performs better than just randomly guessing. And this mean baseline is what we'll get if we just did a random guess. So let's go ahead and look at the visualizations for this. Oh, the metrics. Let me see. Well, I kind of did this all in the same. There we go. All right, and then actually this goes over here, and this goes over here. I like to keep things organized for my own sanity. All right, and then this whole thing actually goes here. Not that it matters too much, but I just like to organize things a little bit. And what else do we need here? Okay, that's pretty much it. And let's see, let's change our variable names. All right, so okay, so basically our random our okay, so basically the features that most determine the customer lifetime value is not exactly the same features that determine um, the insurance premium. So basically, for the insurance premium, what's most important for predicting the insurance premium is these five factors right here, the top five factors here. And for customer lifetime value, what's most important for predicting insurance premium is the number of policies. The customer lifetime value is the number of policies. So, and then income, month since last inception, and a month since last claim. So, that's interesting difference between what predicts the insurance premium and what predicts the customer lifetime value. All right, so that's basically it for the models. I've transferred the models from here to here. Um, Now I'm just gonna focus on the visualizations. So I have a Shapley plot that I built over here. Let me go ahead and find it. All right. Mm, all right, and now let's go ahead and do it for each one of these. So Mm. So we can do kind of like so this is our test data right here. This is a sample of our test data. And let me see. So for the first column here, this is the value. So this is the values located in the first row, not in the first column, in the first row. These are the values. And then we want to do sharply for customer lifetime value. So in this situation, we're doing is for S train. My Y train in this situation is not Y train, it's actually premium train. And then S test. And let's go ahead and run this. Oh yeah, and because this is a visualization, it may not show up properly here. Oh, it did show up here. Interesting. Sometimes visualizations don't show up in Jupyter Lab. That's one of the frustrating things about it. So you really can't see this. Let me go ahead and change my let me go ahead and remove dark mode. Um, mm, well, it's not letting me change it from dark mode. Let me see here. Yeah, for some reason, for some crazy reason, it's not letting me change it to. It's not letting me change it. Let me see. Code mirror. Theme. User preferences. Let me see if this works. It works. It works. Let me see. Let me go ahead here and see. Maybe I need to change it. Okay. All right. So I just changed it to. Let's see if we can see it now. So if we scroll the way down. I prefer dark mode. I don't know about you, but I prefer dark mode. But we can't. Okay, now we can see it very well. So this is our sharp visualization for the insurance premium prediction. Well, and we can try this for like different rows. So we can try random rows like row number 10, for example. Oh, wrong place. So hold on. So here I set the default row number to 0, and here I'm gonna change the row number to 10 for example, and let's see what we get. All right, so basically the prediction is different. So basically what the sharp plot is gonna look like for different rows is gonna be different. So in this situation, it is predicting that the insurance premium is going to be $91.82, and then these are the things that made an impact in this. So it's saying having a two-door, having a luxury XUV, these things reduced the insurance premium, and not having a four-door and having a two-door instead of a four-door increased the insurance premium. And the type of coverage, which is coverage number 2, also increased the insurance premium. So that's one of the things I like about sharply plots. It kind of gives you this visualization of like, hey, this is your prediction, this is what we predict the insurance premium to be, and these are the factors that contribute to that prediction. Of course you can try this for like different rows. So let's do row number 100. So this one for row number 100. So let's see. Zero, I've tried 10, and I've tried 100. Okay. So basically, in this situation, like the insurance premium is going to be really low, and the reason why the insurance premium is super low is because one, it is a two-door. It is a two-door car, okay, and then it's getting the basic insurance type. So basically, the insurance levels are basic, premium, and something else. And the insurance they are getting here is like basic, which is kind of the equivalent of liability insurance. And then they don't have any luxury cars, and then they don't have any luxury cars, they don't have any sports cars. So these are the things that kind of drove down the insurance premium. So we can repeat this process for customer lifetime value to see, okay, this is the predicted customer lifetime value, and these are the factors that's making an impact on that. So actually, I think what will be interesting is if I do this if I have them side by side. So let's do this for row number 100 here. Oh no, 100 here. And this is row number 10, is what we did earlier. And let's do for row number 1. I want to get one that has a really high no. So let me see real quick. I want to find the row that has the highest insurance premium prediction. So let me see the row with the highest insurance premium prediction. So to do this, for this I'm gonna do y-pred r, because that's our prediction. Dot max. Can I do that? Okay. So the mark for let me see, highest insurance premium value prediction. So basically this is the yeah, and then I want to get the row with the highest insurance premium prediction. So I believe the syntax I'm looking for is argmax. Alright, so basically row number 357 has a predicted insurance premium of $284.99. So let's go ahead and see and let's call this row number 357. All right, so basically in this situation what it's saying that the predicted value is $273.50, um which is not this, because let me see. Sharp is predicting $273.50, but our random forest model it says it's $284.99. But I'm trying to see the, let me go back here real quick. So I see what the problem is. So I'm not using the default. In the original random forest model that I built earlier, I just used the default value. I didn't specify anything, and for this sharply I used a different mod. That's why the result I'm getting, that's why the result here from my prediction earlier is different from the result here from my sharply. So it's good that I got that. I want to make sure I use this model. And now if I run this, it should say oops, wrong one. Yeah, there we go. If I run this now, it should say $284.99. There we go. That makes a whole lot of sense now. So with an insurance premium of $284.99, these are the factors that contributed to such a high insurance premium. One, they have a luxury car, and they got the premium coverage. So there's different coverage levels, right? There's like liability, then there's like one above that, and then there's like premium, which is coverage number 3 here, and that is what contributed to such a high insurance premium. So now let's repeat the same process, but for like let's repeat it for like the minimum value. Let's see what the minimum insurance premium is. Give me a second here. Okay, so the lowest insurance premium value prediction is $61, and the row with the lowest insurance premium prediction is, let's find out. So argmin is row number 931. So let's change this to 931, shall we? So basically, the insurance premium here is $61, and these are the things that contributed to such a low insurance premium value. It has a four-door car and it has a liability. Those are the two big factors. It doesn't have a luxury XUV. They have so is this like monthly income, or is this, oh, I need to verify this information. Is this monthly income or annual income? I think it might be monthly, and then other factors. So it's been 7 months since their last claim and stuff like that. So this is the sharp plot for the lowest values, and of course, let's try one for the mean value. Why not? I wonder if I could get, let's say, so that's the mean, but let me see. When I did I don't think arg mean is a thing in Python. I'm just making this up. Yeah. So let me see. I want to find the row that has a value close to the mean value. So let me see. I remember when I did was it number 0? The prediction was no. I think we had one that yeah. So for row number 10, the predicted value is kind of very close to the mean value here. So all right, so so row number 10 kind of gives us an idea of like if your insurance premium is like around the mean value, these are the things that would kind of like contribute to it. I haven't pushed the GitHub since I started working. Let's go ahead and do that, shall we? Let's go ahead and do git add, git commit, working on visualization, git push. All right, let's go here and refresh this. Working on visualizations, yay, 16 seconds ago. Whenever I push something to GitHub, I always go to GitHub and verify that it's there, because I've had instances where I push something to GitHub. When I went to GitHub, it wasn't there. Then I realized I pushed to the wrong repo. Yes, that has happened before. So always verify that your push to GitHub was done accurately. So now we are gonna repeat everything that we did above, but we are gonna repeat it we are gonna do it for our customer lifetime value. And I'm gonna stay in light mode for a little bit longer until I'm done with these sharply visualizations. So It's just gonna be a lot of copy and pasting. All right. So row number 1357. And we're gonna change this to all right. So basically, wow, that's a that's a lot of numbers. So so this is the customer that had the highest predicted lifetime value to the insurance company. All right, and the thing that kind of contributed to this prediction is they had two policies. So the number of policies was two. They had a luxury XUV. It's been almost 3 years since their last claim, and they didn't have any four door. And then but then they had a liability coverage. Okay, so I wonder what the insurance premium is. So let's see. Insurance premium for customer with highest lifetime value. All right, so we could let me go ahead and we could mm, so we could kind of be like, okay, so if this is the customer with the highest lifetime value, how much does the insurance cost? All right, so we just change this to premium, and then we'll run this. Okay, so so this customer that has the highest customer lifetime value, right? The insurance premium is really high at $192. So the insurance premium is really high. And then we can also repeat this process, but we can do it the other way around, right? So we can be like, okay, so if this is the average insurance premium, so what is the customer lifetime value of the average insurance customer, to the insurance company. So basically take this right here, and then we'll change this to CLV. Remember, we are using the same X training data to predict insurance premium and customer lifetime value. All right, so basically for the average customer, their customer lifetime value to that company is about $7,463. Let's repeat this process. But for lowest, right? So instead of this, so since we'll do 931 here, and let's run this. So basically for this customer, their lifetime value to the company is about $2,227. Wow, that's interesting stuff. And now let's see, let's do the same thing for the customer with their highest insurance premium. All right, so I want to make sure I label this correctly. If I can spell today. All right, and let's do the same thing for the average. All right, so now let's do row number 357. All right, so basically this customer that pays $284 per month for the insurance premium, their lifetime value to the company is $31,000, but they are not the highest. They are not the customer with the highest lifetime value. So not the customer with highest lifetime value. All right, so they don't have the highest lifetime value to the customer. Okay, but this number is predicted from, like, they had number of policies. They have 2 policies, and they have 1 luxury car, and they have the coverage level 3. But then if we scroll down here to the customer with the highest lifetime value, they had actually a lower coverage level. Okay, and they still had the same number of policies. They still had a luxury SUV. So this has a luxury XUV. Let me see. This one just had one luxury car, and then the coverage level is number 3. So for this one, the coverage level is number 3, and that's kind of part of what drove up their insurance premium, right? And but for this one, the coverage level is 1. So they have the liability. So maybe people that have liability insurance is more valuable to the insurance company, probably because they'll last longer, because the insurance premium is low. I don't know. I think my insurance premium is high. My current insurance premium is high, and I have just liability. But then I live in Seattle, so I think one thing that might have a big impact on insurance premium is not necessarily the state you live in, but the city you live in, right? So if I lived in Eastern Washington, that's mostly desert, my insurance premium is gonna be low because it's less populated. And not only is it less populated, it's less traffic, less risk for the insurance company, less everything. But if I live in a place like Seattle, where it's highly populated, there's heavy traffic here, and we park on the streets, so that's all of that pose a huge risk for the insurance company. So the insurance premium is gonna be a bit higher, so I think another like big predictor of insurance premium is would most likely be the city, but we don't have the city data in this data set. But that's okay. The factors we do have still helps a bit, but I think city would have been would have been a good predictor of insurance premium. And it would have been fun to look at, hey, insurance premium in multiple cities in the same state. For example, I live in Washington, right? So it would have been fun to look at, hey, insurance premium in places like Seattle, Kirkland, Bellevue, the big cities of Washington, versus looking at the insurance premium in places like Spokane, Tacoma, and other parts of Washington, other cities in Washington. That would be a fun project if I could get my hands on that data. It would be a fun continuation of this current project. With that being said, though, let's keep going. All right, so this is the customer that had the highest insurance premium prediction, and this is how much the insurance premium cost. This is the customer with the highest lifetime value, and this is how much the insurance premium cost. And let's do the same thing for. All right, so basically the customer that has the lowest lifetime value to the customer. Also, so this is 0785, and let's change this to CLV. All right, so these are the things that contributed into this customer having the lowest lifetime value to the insurance company. They had one policy, they had a 4-door, they had a liability insurance level, and the income value says 0. So, and now we can do this and be like, okay, so what was the insurance premium? Okay, so Alright, so the insurance premium was pretty low at $65. So that's not bad. Yeah, predicted insurance premium is really low at $55. So now let's do this for the oh, by the way, if you click on something like this, if you click on the key like this and press M, it changes it from code to markdown. All right, so let me call this lowest customer lifetime value, and let's repeat the same process for this so that I'm keeping good track of what I'm doing. So if you just press M, it will change it into a markdown. And then let's do it for the average. If you keep an eye here, when I press M, changes to markdown. I think that's cool. So basically the average customer lifetime value is about $7,927. If you scroll back up here and then look at this here, it tells us for this customer right here, their lifetime value was $7,463. That's pretty close to the average that we determined here. We can try to find let me see. I was trying to think if we could find a row that was closer to this, but I think what we had above for row number 10 is pretty good. We can try out different rows, and just play around with this. Yeah, so we can play around with different rows here. Just for fun. Anyway, so that's it for the sharply plot visualization that I wanted to create. That's fun, and of course all of this is going to go in the app, so I'm super excited about that. Next week we'll start working on the app, and we are going to be using Plotly Dash to build the app. And the way the app is gonna work is like you'll be able to get a prediction, you'll be able to look at visualization, you'll be able to look at the process. It's going to be a whole lot of fun. So now let's focus on Plotly visualization. So we've done the sharp plot visualizations. Let's focus on Plotly visualizations. All right, so I think I have my Plotly visualizations up here, and this is the part where I may need to switch to Jupyter Notebook, because Jupyter Lab is having problems displaying Plotly graphs. It'd be nice if I can just find what I'm looking for. This is exactly why I am. This is exactly why I'm refactoring the code, because the original one had like so much stuff. That's why I'm refactoring it. So wrangling. Okay, there we go. So first and foremost, let's go ahead and, oh no, wrong place. Let's go and import plotly express as px. For insurance premium. Uh, mm, mm. All right. So let me just go ahead and do this here. So these are some visualizations. Hmm. Let me see. So these are just a few more visualizations that I created for this project. Uh, so this was a 3D graph. All right, so that's goes. Mm, mm, mm. Okay, so all right, so I've copied over the code for the visualizations, and of course, as time goes by, I could create more visualizations, but let's just work with what we have here for now. And let me see. I may have to. Okay, so uh, I want to I may have to go back all the way up here. Let me see how I did this. Wrangling the data, splitting the data, renaming the columns. Okay. So I split from train 2 and there's 2. Alright. So train 2. Alright. Alright. I want to see before I split into train test split. Okay, so I did the split very on in the data set. I split into train test validation very early on in the data set. So for this particular visualization, I'm just going to be pulling from the training data. I'm confident that the visualization we obtain from the training data is going to be similar to the visualization we would have obtained if we were like creating visualization from the entire data set. Alright, so and this insurance too, I can't use it for the visualization because of encoding. So later on in the code, I change all these value, all these letters, all these strings into values. All right, so yeah. All right, I just wanted to verify what I had. Let's go ahead and look at the visualizations. If it doesn't show up here, we'll switch to Jupyter Notebook. And this is basically the last thing I was gonna look at today. Just do the visualizations, and that's it. This project is pretty much done. This was the original notebook here, and this notebook is refactoring this notebook, and yeah, so after this is done, this notebook is pretty much done. Oh, I also want to export the models. Export the models here, and next week we'll start building the app. So I'm super excited. We are gonna take this everything in this notebook, and we are gonna put it in an app. So we are going to have so much fun. I promise. All right. Um. So what I want to do here is I want to do what just happened? Uh I don't know what happened. It looks like the code got deleted or somehow. Oh, okay. Okay, for a second there, I thought my code got deleted. I was like, what's going on? Alright, so this is the original data that has been encoded, and it has everything, including um, monthly premium auto and customer lifetime value. Customer lifetime value. So train 2 is the data set that has everything. So this was before I defined my x values and my y variables. So we'll just change this to, and we'll run this. And it's not showing up as expected. So since this is not showing up, let's go ahead and boot up Jupyter Notebook. But before I do that, let me go ahead and add this to GitHub. So git add, git commit message about done with sharply, about to do plotly graphs. All right, so I have to make sure git push. All right, let's go ahead and refresh this. All right, it's there. So now I'll just get Jupyter Notebook and run these code cells here. And run these code cells. That's pretty much the only thing left. Well, I still want to export to the model. I'm gonna do that actually right now. So before I switch to Jupyter Notebook to be able to see these visualizations, or we could even do it in VS Code. Doesn't matter. So if we go back here, right, so we can see that this was okay. So if we go back here, right, so the model that we used here is, the name of the model is RF model CLV. Okay, and then so we are going to export this model, and we are going to export our that model. All right, So let me go ahead and copy these two right here. After exporting it, we're gonna import it again just to verify that it works. You know. And all right, so those are the models. I just put it there so that I don't have to scroll back up to find them. So we are going to be using job lib. All right, so I'm gonna go to my website real quick, and I have a blog post that shows how to export your model. Yes, I reference my own blog posts often because sometimes I forget stuff. So I don't know if it's in this blog. There it is. Yeah, so this is exactly what I'm looking for right here. So expert insurance premium project model for prediction. So basically the whole point of do I need to import joblib first? Let me check. Oh yeah. First I need to have joblib. So this so this right here just means to use to do a shell command inside a notebook. But it looks like I already have joblib, so I don't even need to install it. But if you didn't have joblib, you can use this to install it in your computer. But I already have it, so I want to dump this. I want to dump RF model. All right, and then all right, let's call it let's call it of course it's not import joblib. You know, it would be nice if I could type today. All right, so let's run this now. So now if I go to my file, you see there's a new file called why can't I stretch this out? Yeah, see there's a new file called insurancepremium.pkl. So this insurancepremium.pkl is basically the same thing as my insurance premium model. Let me go ahead and okay, it's basically the same thing as this model right here. It's the same thing as this model right here, but I have taken this model and I have saved it into a file so that when I'm building my app, I don't have to retrain the model every single time. I can just use it to get a prediction. And I'm gonna show you what I mean here in a second. So if I scroll down here and then I do new model, let's just go, it's equal to jobly.load, and I want to load this. Alright, and now I want to use it for prediction. And in this case, I want to use it to get predict S test. Alright, and then let's type in alright, so we are able to use our saved model to get a prediction. And if you remember earlier here, the prediction that we did here was saved under, it was saved under ypred r. So let's go ahead and copy this, scroll down here, and then as you can see, the values here that we got from our loaded model is the exact same value here that we got from our original prediction. I just wanted to show you that it works. All right, so now that we have saved our model, let's go ahead and do the same thing for customer lifetime value. So I'm just gonna say, I'm gonna call this all right, and we already have job lib that. So exporting insurance premium project, exporting customer lifetime. So let's call it customer lifetime, and we need to be dumping this one. This is one of the other reasons why I use different names for the different models, so that I don't override it, so that in situations like this, when I need to use them independently, I won't have to go back and rerun the code again in order to store the new model inside the same variable. So basically using the same using different variable names is good, so you won't override things, just in case you need to reuse that variable again. And just as expected, we have a new, well, we should have a new, there it is, we have a new file called customer lifetime value.pkl, and we're just gonna verify that it works, because we are a bit paranoid. Well, I am a bit paranoid when it comes to code. I don't assume it works, I just test it out to make sure it works. We want to load customer lifetime value, and we want to use it to get a prediction. Let's call it 2. And just for sanity check real quick, we are just gonna do ypred r clv, As you can see, the values that we have here using our saved model is the exact same thing that we got earlier from the model, you know, before it was saved. So I just wanted to show that. All right. So now that we have saved the model, next, like I keep saying, next week when we start building the app, we are going to be using this model for predictions. So basically, instead of us running this code cell again, or instead of us taking all this code and putting it in our Python app, in our Python data science application, we can just use the saved model, right? So the saved model is all that we are going to need. If we didn't save the model, when we are building the app, we have to tell the app, hey, this is, we have to like write code that says this is X train, this is Y train, this is this. So basically you have to take all majority of this code here and write it all over again. And I don't like rewriting code. So that's why we are saving the model. So next time when we need to do this, we can just provide a value right here to get a prediction. And with that being said, let's go ahead and push to GitHub and then switch to Jupyter Notebook so we can see our visualizations, and then we are pretty much done for today. So git add, git commit, git commit, done with saving model, git push, all right. Let's go here to double check. Let's go to model, and we have our two new files right here, so that's pretty good. All right, let me see. So I used Anaconda prompt to launch this Jupyter lab. Okay. And just because I exited it from this notebook right here online, it's saying that we are disconnected, which is what we expect. All right. So let's go back here and then all right. I don't think I created I think I had a virtual environment for this project. Let me just check. We're gonna deactivate. Okay. Yeah. See, I had a virtual environment for this project because I was like, wait. So see, I have a pip file and I have a pip file log. I have to make sure I add job lib to the virtual environment. And once I start building the app, I might switch Docker to Docker. So next week when I am actually building the app, I am going to be using Docker for the environment. But for this project, I was just using a virtual environment. So pipenv shell, pipenv install joblib. I want to make sure I have joblib in this environment because I have joblib in Anaconda, and I think I was using Anaconda there for a second. But if I want to make sure I have joblib in the virtual environment. Give it a second. Once it's done, then we'll switch over to Jupyter Notebook. I think that's the only thing that I need to make sure is in the virtual environment. Scikit-learn is already there. Yeah, that's the only new package I installed. I guess we'll just patiently wait. How long is it gonna take it to lock? Oh my gosh. It's taking forever. It's taking forever. Forever. Um well, while this is having fun doing what it's doing, let's go ahead and see if we can launch Anaconda here. Let's go ahead and launch the notebook from Anaconda Navigator. Well, I could open another Anaconda prompt. Hold up. Actually, I want to make sure I let me see. Yeah. All right. So while the virtual environment is locking, we are just going to use Conda base for the notebook to keep working. And in the future, if I'm working on this project, I'll probably switch from Conda to the virtual environment. But right now, the virtual environment is taking forever, and I don't want to wait. So we want to get into data. We want to get into just kidding. We want to get into model, and we want to get into this one. All right, let's go ahead and run everything. So no, was cell, run cells, run all. So, oops. I don't think I want to run this once again down here, but it's fine. So let's see here. All right. So everything is running smoothly. This virtual environment is still locking and it's making me mad. Thank goodness I didn't wait for it. All right, so okay. Well, it didn't where's the visualization? Why is Plotly Express not working? Plotly Express is not working. This is making me mad. It's not showing the graph. Um all right. Let's switch to VS Code. Well, could I change the maybe it's because of this. I don't think I can change the um no, that shouldn't be the problem. Let's switch to VS Code. Let's go ahead and shut this one down. For some reason, it is not working. Let's switch to VS Code. I don't know why Plotly Express is not working in Jupyter Lab or Jupyter Notebook. And this is still locking. Great. So let's do this. Well, you are no fun, Google. I mean, not Google. Let me see. Why is it not showing up? So let me see. Explorer. Okay, this is strange. Before. Huh. So where is the folder? Why is it not showing me the folder? You know, this is annoying when things don't work. So why is it pulling up let me see if I can try something else. Before it used to be that whenever I did code dot, it will open the folder and everything inside. But now it doesn't work like that anymore. And it's making me mad. Nope. let's do it the old-fashioned way. For some reason, things are not working. So this is still locking, and then hmm. So I'm gonna switch it to Conda base. Mm, mm, mm. Which one is this? Let me see. Why is it not giving me the base? So here I'm using Conda, and I don't want to use. Okay, hold on. All right. Fingers crossed. Stuff works like it's supposed to now. I don't want to use this virtual environment because it is still locking. Let me go ahead and run everything. Finally, the graphs are working. Oh my gosh. uh, all right, so I need to figure out why Plotly Express is not working in Jupyter Notebook or Jupyter Lab, but it works inside VS Code Notebook. So anyway, so this is the graph here. It doesn't look super impressive. Month since last inception and monthly premium auto. And then this is another graph here. Oh, I think because this graph is so crowded, I think that's why I wanted to get some samples. So and then let me see. This is for customer lifetime value and month since last inception. The graph doesn't look that impressive. Nothing there to see. And this is a lot of data. Oh, this looks super cool. So this one, so this is kind of like looking at the relationship between customer lifetime value and monthly premium auto. This is what the graph looks like. Actually, I think I might include this graph in the app because this graph is, I'm not gonna lie, super cool. So for a customer lifetime value here and a monthly premium auto, um, higher customer lifetime values also it's also correlated with like higher insurance premiums. So okay, this is super cool. This is too much data. It's kind of difficult to kind of visualize what's going on. So I think that's why I wanted to create samples. So let me go ahead and get a sample data set. Actually, if I go to this here, uh, let me see. Let's keep scrolling. Give me 1 second here. There we go. So basically, this is a sample of the data. So let's that's strange. Why is it saying 22 is not? Let's see. Um, I think I may have to rerun this from the beginning. What the heck is going on? Um, is it because of the kernel? No. I just run this from beginning to end. It was working, and then all of a sudden it starts working. Okay, now that this is done encoding, let me go ahead and switch to um, mm, mm, mm. Why is it not okay? So this is very strange. um I'm trying to change the kernel to this virtual environment, but it's not showing up. mm, do I need to close this out completely? And why is it's not, something's not right. I don't know what's going on. Every other virtual environment but this one that says insurance premium prediction ppm should be here, but it's not showing up. Well, let me see. Let me try running it again. I don't know what's going on with this thing, but anyway, our pip file was able to finally lock. It says installing failed dependencies 3 out of 3. So even though it failed initially, it was able to successfully install it. So that's good. So let's go here. So yeah, I think the problem we are having is that for some reason in VS Code, it restarted the kernel. Like, what the heck? All right. So let's get so now that we have our sample data, let's go ahead and use the sample data here instead. Yeah, so it looks a whole lot cleaner, with the sample data. Yeah, I mean, it doesn't look that much. It doesn't look like a whole lot, but you can see things a whole lot better. But the sample data will really come in handy when it comes to something like this one. Same thing, but it doesn't look so dense. Maybe let's make it a sample of 500. Let's make it a sample of 500. And this graph right here is one I'm really interested in. Yeah, it looks similar to what we had earlier, but less data. But the training sample will come in really handy right here. So because of the training sample, it's just a lot easier to see things. So I think for this one I'm just gonna use the data set, the original data set. But for the 3D graph, I'll use the training sample. I think that's how I'm gonna do it. So and let's run this. All right, so it does look a whole lot better. It makes it easier to look at the data right here. So I think the graphs I'm going to include is this one, just because it's eye candy, it looks good, and this one. And the other graphs doesn't look that impressive, you know. And then of course I'm also going to include these visualizations for the Shapley, and also I'm going to include these visualizations right here. That's pretty much it. Thank you for sticking with me almost to the end. There's nothing much to see here. We are pretty much done building this model. Like I'm very satisfied with what we've done so far. Next week we'll start building the app. We'll just take all of this and we are going to build an app. And the way the app is going to work is you go to the website, you enter your you enter your different values, and you'll be able to get prediction for your insurance premium, and you'll be able to get predictions for customer lifetime value. And then you can look at the visualizations and you can play around with Shapley plot visualizations, and you'll be able to look at the process, in the website. So all of this is going to be in an app that we are going to launch next week. And it might take me like several weeks to kind of like build out the app, because this is the first time I've actually built an app like this. So it's gonna be a learning process for me too. So I'm excited. All right, with that being said, thank you so much for watching, and I'll talk to you next time. If you have any questions, be sure to let me know in the comment section below. Bye.